So today we're going to pick up where we left off last time. Okay. Oh, good God, what's going on here? Okay, I don't know what happened there. So yeah, that's my table of contents for today. So I hope the rest of the presentation is as clear. We're going to pick up where we left off last time. I'll just go back to here. Yesterday, you may remember, we figured out how to estimate employment impacts from the policy scenarios that we modeled at the macro level, carry that to the micro level, and look at figuring out which records we can say get the new jobs that are created by the policy interventions that we modeled at the top. Right? So it's a top-down model. So we start at the top and we go to the bottom, and the bottom is the household survey data. So that's what we did yesterday. Today we're going to kind of complete the analysis by looking at the direct impacts of the policy interventions on people's time use, as well as the indirect impact on people's time use via employment changes. Right? So that's what we're going to do today. So it's all going to be about time. And so let's hope I can use my time wisely. So just to kind of bring you back to the very first session on this macro-micro model and the measurement of time poverty, right? So this is how we measure time deficits, right? So we look at a week's worth of hours, right? That's 168 hours every week. And from that, we subtract some time for personal care. So we have a personal care threshold. And then we subtract the time spent on required household production, which is the household level threshold for household production, times the individual's share of required household production, which we estimate by looking at their share of actual household production time. And then we also subtract the time spent on commuting for people who are engaged in income generating activities. The D is the dummy for engaging in income generating activities. And then we also subtract the time spent on income generating activities. So after we subtract all that out, what we have left is Xij. If after we subtract, if all of these things add up to more than 168, right, we say that this person has a time deficit. Right? They can't do all the things they need to do. They can't take care of themselves, take care of the household responsibilities, and take care of generating income, because there aren't enough hours in the week, literally. Right? So something is obviously giving for that person. Something has to give. So people can be time poor for a variety of reasons, right? Too much work in income generating activities, too much of the household production responsibilities, etc. So that's the baseline. Now prior to this project, we had already estimated this for everybody in Ghana and Tanzania, but now we're going to change some things, right? So we're going to build roads. Right. We're going to expand early childhood education. And so let's see what happens to time deficits based on those policy interventions, right? So for road improvements, what happens is we have an adjusted threshold of commuting time, right? So the new time deficit for individuals is going to be, excuse me, the old time deficit minus the difference, right? So if this is new, if the new adjusted threshold of commuting time is lower for people who are commuting, then you'll have lower time deficits. So the change in the threshold times the dummy for engaging in income generating activities gives you the change in time deficits. For the early childhood education expansion, we have another altered time deficit for individuals, and this is, here's a new dummy, and this is for living in a household with a young child, right? So below the school age, primary school age. So here we have the adjusted threshold for required household production due to the expansion of early childhood education, right? Times the adjusted share, right, of household production due to the new requirements, minus their old share, right? So this is the new amount of time that individual I and household J spends on required household production. And this is the old. And so we only calculate this, it only changes for people in households with young children, right? Because they're the ones who will be in the expanded early childhood education sector. Okay, so that's those are the two policy interventions. And so if we do them separately, if we do one, if we do the road improvements, we get this changed time deficit. If we do the early childhood early child education expansion, we get this. And this is what my English sounds like after 5 hours of sleep, by the way. So if you're wondering why I can't speak, that's why. Okay, so those are the two scenarios. Now, of course, the third scenario is the total effect from both, right? Because we also model doing both at the same time. And so basically, it's just you add these two changes together, right? This comes here, and this comes here. And so this is the direct effect impact on, this is the time deficit of individual I and household J under the direct effect, right? So this is the total change as a result, direct result of the policy interventions that we're modeling. So these are the changes in time deficits for individuals. So it's the change in commuting time, and it's the change in household production hours. Okay. Now there's an additional effect, right? So we have this first line here. So we have the total effects are the first line minus the second line, right? So there's a change in household in income generating time for people who receive jobs in the simulation. There's an adjusted time spent on household activities, right? Because if for people who get jobs, right? So people, D2 is the dummy for people living in a household with a job recipient, right? So they're going to have a different share of household production hours. So this is a new dummy for engaging in income generating activities as well, because this is now different, right? Because more people are employed than before. So this is the total effect, right? So nice and simple, right? Sure, they say, sure it is, simple. But it's basically just looking at so three things are changing, really. The time spent on commuting for people who have jobs changes due to the road improvements. You know, there are other things that change, but we don't model those. The time people spend on household production work changes for people in households with young children who are now in early childhood education as a result of the policy. And the time spent on household production activities changes for everybody in households with in which there have been job transitions as a result of the expanded employment, as a result of the spillover effects of the policy interventions, right? So it creates new employment, more people are engaged in income generating activities, and so there are readjustments in household production time.
Tom, there is one question from Erica.
Okay, Erica, yes.
Hello, good morning.
Good morning.
I am curious about childcare.
Yes.
When the children will go in childcare facilities, of course, you subtract the time the time for direct childcare. But did you calculate also the household production that is connected to the children at home, like cooking less? I mean, if the children is not at home, you spend less time cooking. That is not direct childcare.
Yeah. So the question really is how we calculate the new adjusted thresholds for household.
Yes.
And I'm going to get to that.
Okay.
I promise.
Thank you.
It's like 3 slides away from where we are now. But first, I'm going to talk about the road improvements, and then that. Okay. But we go through statistical manipulations to adjust both of those thresholds: the commuting time and the household production time. Yeah. So so we look at total time spent, and we basically look at we compare households that where the kids are not in childcare with households where they are, right? And we look at the average difference and we adjust thresholds that way. But let's see. Okay, so the total effects of policy interventions on household time deficits and consumption poverty lines looks like this. So we have the time deficits of households, right, which is you add up all the time deficits of the individuals within the household, right? That's what this is. Oh, did I say max? I just realized I answered somebody incorrectly. Was that somebody in this class? I'll have to go back and look. We use the minimum function, right? Because we're negative. So household deficit, individual time deficits are negative. You add them all up, and oh, this is, okay. All of these are wrong. This is terrible. So you add up for each individual 0 or their time deficit if they have a time deficit, right? The point is you don't add surpluses, and we don't do that because we don't observe people shifting, right? What we observe is some people have surpluses and some people don't. So we're not going to say that there's some way that the surpluses cancel out the deficits, because they're not. We don't see them canceling out, right? If they were canceling out, then the person with the deficit would have a lower deficit, and the people with the surplus would not have a surplus, right? So we just add up the time deficits of all the individuals in the households. And so for the baseline, it's just the original deficits that we're going to add up. For the direct effects, it's the direct effect deficits that will add up. And for the total effects, it's the total effect deficits, right? Pretty basic. To get the adjusted poverty line for each household, right? We take the official poverty line, which is this Y bar J, right, for household J. And we say for household J because in some cases, it's a equivalent expenditure threshold, right? Equivalent adult, per capita equivalent adult expenditures, for example, right? And so we take that original official poverty line and we adjust it by the replacement cost of the time deficit for the household, right? So P is the replacement cost, and we get that by looking at the wages paid to domestic servants in that labor market. Okay. So that's how we adjust the poverty line. So if a household's deficit is smaller because of the change, right, the adjusted poverty line will be smaller, right? And so they might leave poverty just because of lower commute times or less time spent on household production time. But if it's higher, the opposite could happen. So it's not entirely clear. In terms of consumption expenditures, right, there's no direct effect on consumption expenditures, but the total effect includes the increased expenditures due to increased earnings from within households where where there are job recipients in the simulation. Okay. Okay. Questions so far? Now we're going to get into how we estimate each component. But this is the kind of framework that we're using. Now we have to figure out how to plug in, which numbers to plug in these places. So, okay, great. First, we're going to model the determination of household production and commuting time for individuals, right? And so we model how much time individuals allocate to household production using a censored regression Tobit model with data from the time use surveys, right, for each country. And then we estimate similar models for time spent commuting. Okay. And so I'm not even looking at my notes. Why do I even have notes? So the policy variable is Z, right? So for what we do is we have the time spent, we have a set of characteristics for individuals or households, depending on for individuals and households, right? But this is calculated at the individual level. And then we have the policy variable Z, right? So for the road improvements, this ends up being the percentage of in decent shape by region, right? And so we're going to alter that in the policy, right? So we have the actual amount, and then we're going to alter it according to the policy goal that we set out in the very first lecture with Ajit, right? For the early childhood education expansion, this is, are your kids in childcare or not? And so we change that, right, for households with young children where they go in, right? And for the policy scenarios where we don't go for 100% early childhood education, there's a random selection, right? We randomly assign households to get their kids into the early childhood education. And so for the households that get that, we then use the results of the estimation with the actual data. We predict with the altered policy variable, right? So in other words, we run the regression for commuting time using the actual percent of decent roads, and then we use a prediction based on that estimation to predict the commuting time with improved roads, right? So a new share of decent roads. And similarly for childcare, right? So the estimated parameters are transferred to the synthetic data set, and then the final impact is estimated like this. So the change in household production time or commuting hours, right, it's based on the change in the policy variable and the estimated parameters from the model. Okay. So that's how we take into account, the differences in household production requirements between households where kids are in school and not, right? So that's what we're looking at here. That's the policy variable. That's the work that the policy variable is doing in the model, right? So it's going to give us the change in commuting time thresholds or household production thresholds.
Tom, there's a question in the chat. I don't know if you want to address it right now from Deborah.
Let me see. So the medium to long, that can, yeah, increase balance, yeah. Yeah. So yeah, none of that is observable or included in the model, unfortunately, right? So because we're using cross-sectional data from, for Ghana, it's from 2012 Living Standards Survey. For Tanzania, it's the 2012 Household Budget Survey. We can observe, we can only observe differences, between households that have access to good roads and don't, right? And so, these are all kind of omitted variables. And in the short run, and in the medium to long run, we just don't know, because we don't have a model of how roads affect that in the long run. So unfortunately, the answer is no. Right, the age range of the children being considered is different for the different countries, unfortunately. And I don't remember, that was a JIT's presentation way back when we were all much younger. What was that, Thursday? So I can, yeah, so first, right, so in both countries, a 12-year-old is already in school, generally speaking. So we're only modeling the impact of children under the age of 6 being taken into the school system. And I don't think that we differentiated by age within that group. So, okay. Any other questions? You can read the kind of comprehensive, minute details in the appendices in the report. That's the reading for all of these sessions, right? The main report for this project. There's an entire appendix devoted to this this method that we used. And it has a lot of limitations in addition to the ones mentioned in the questions in the chat, right, Deborah? These are rough. We only have regional level variation captured here for the commuting time, for example. There's a little bit better information for the access to childcare, but it's not perfect either. But to summarize, to paraphrase Donald Rumsfeld, who recently left the earth, you go into analysis with the data you have, not with the data you would like to have, right? So we have what we have, and that's what we use. So we do the best we can with what we have. Okay. So we estimate the impacts this way, and then step 2 is we apply the policy changes and compare predictions, right? So we simulate changes in time allocation associated with the proposed policies using the results of the Tobit models, right? We compare predicted household production hours with actual and target enrollment rates, right? For roads, we compare predicted commuting time with actual and targeted percentage of paved roads. And so then we re-estimate the required household production thresholds and commuting time thresholds, and then we use those new thresholds, right, to recalculate LIM TCP, so time and consumption poverty for everyone. Okay. And then once we're done, we can compare the results, right, and see what happens to time and consumption poverty, at least what we estimate to happen based on the information we have, right? So we see shorter commuting times, we see less time spent on household production, although not much, right? But some. Basically, the early childhood education, right, as we've talked about before, is really only going to substitute for the time spent solely on supervisory care. Right? So if you're doing other things as well, then that's not going to go away, right? But things like less cooking may be the case, although, some of the schools we visited, parents brought lunches, right? Cooked lunches and brought them to the school. So, it all depends. Okay. So have I answered your question, Erica? Make a call back to Erica's question.
Yes, thank you.
Okay. So that's the process of estimating direct effects, right? And so that gives us all the different parameters that I put up on all those slides with all the fancy math equations, right? They aren't all that fancy, right? They're just, the words are escaping me once again. It's addition and subtraction is all it is that we're doing. A little bit of multiplication, but not too much, right? Okay, so the tricky part, and frankly the part I did, not this, all of this was done by Tamar Kidarashvili, Kijong Kim, and Fernando Rios Avila. So the part that I did, was the reassignment of household production time. And so you all remember assigning jobs last time, right? And the hot decking procedure that we used to do that. We're going to use the same method, hot decking, to reassign household production time. Okay. So once again, we go through a set of steps. And again, we identify donors and recipients first, right? In this case, the recipients are all the adults in households where somebody received a job in the employment simulation, right? Because those are the households where household production, shares of household production time are going to be redistributed as a result of the change in time spent among individuals in the household on income generating activities. Right? So we're going to assume that there's some difference in household production hours for all the people in that household. Okay. So the donors are all adults, basically. So because all adults live in households where some people work. Okay, in income generating activities. Okay. Now we're going to divide the data set into subsets by age category and sex of the individual. And then we're going to use the simulated hours and number of earners. So this is the simulated hours of income generating activities, so paid work, right? So which is the actual hours for the people who were already working for pay, plus the simulated hours of people working for pay who got jobs. We're going to use the number of earners in the households for recipients, right? And the actual characteristics for donors, plus other appropriate variables like the number of children, number of adults, region, urban, rural, location, etc. And so we're going to use all the variables we can think of that matter to generate an affinity score, just like we did last time, right, for employment. But we're going to use different variables in this case because there's a different set of variables that are important when we're matching household production time spent as opposed to jobs. No, it's so Carolina asks if the idea is that unpaid work is distributed in the recipients as paid work. No, that's not what we're doing. What we're doing is we're redistributing the unpaid household work, right? Within households where there are changes in employment structure, right? So if you're in a household where, two of the adults were working and one was not before, and now one is, now they're all working for pay outside the house, right? There's going to be some adjustment for all the members of the household, all the adults in the household in terms of household production hours, right? So what we're going to do then for that household where, now all three people are working, we're going to try to find for each of those individuals a match from another household where there are three adults working and the same number of kids, say, in the same region, in the same rural or urban setting, et cetera, et cetera, et cetera, right? And so we're going to look at how the shares look in those households and transfer. Okay. So again, we pick for each individual, we pick randomly from among the donors with the highest affinity score that we generate. And then we assign that donor's hours of household production to the recipient. So all of the recipients, all of the adults in each household where there was a job recipient in the employment simulation are assigned new hours of household production, right? And then we use the newly assigned hours of household production to calculate each individual's share, the alpha ij's, right? So we add them all together and each individual, so if it adds up to 60 or whatever, and if each individual ends up with 20, then each individual's alpha ij is 0.33, right? Right, so that would be great if we could do that, Deborah, but unfortunately we have a sample and so you don't have an entire neighborhood, right? And depending on the time use survey, most time use surveys don't have good information about the time spent by people outside the household watching your kids, right? So that information is not generally available, although there is information about people in the household watching other people's kids, right? There's not the inverse. So unfortunately, we can't do that, right? And it's too bad because that's an important source of supervisory care for a lot of families in Ghana and Tanzania and in the US for that matter, right? So in every country. At least in all those countries where quality childcare is not cheap and easily available, right? Which is, let me check, almost every country, right? So, so now we have newly assigned hours of household. We have a newly assigned share of required household production for everybody. Right. So now we have everything we need. We have the new commuting threshold. We have the new required hours of household production threshold, right, for every household. And we have the new shares of household production for every individual, right? And so for people where there was no change in, for people in households with no change in employment status for anybody, they keep their old hours, right, and their old shares. So they don't have an impact from the employment changes, but they might have an impact from the direct effects, right, the commuting time, or the or the childcare. All right. And then we just do a bunch of addition and subtraction, recalculate time and consumption poverty, and we're done. We can start to look at fun results, right? But first, let's see. Once we do this reassignment, we do some checks just to make sure that we're not completely out to lunch in terms of the assignments we made. So these are median and mean household production hour ratio of recipient to donor by country, sex, and age category. Right. And so, we'd like to see them all at exactly 100%, maybe. But again, as there's less in the employment simulation, there's going to be even more variation because there is more variation in wages, right? In this simulation, there is not as much variation in hours of household production across individuals in each country. And so we're not going to expect to see that big a variation between recipients and donors. But, you'll notice a lot of blank medians among men in Ghana, which means the median for the donor is 0, right? So it's a smoking gun right there. Right? So 50% of the men, 50% of the male donors do no work in the household. How about that? Okay. So
there's another question in the chat.
oh, okay. For matching donors and recipients at this stage. Okay. So the matching variables are the number of earners in the household, so the number of people involved in income generating activities, number of adults, number of children, education, location, rural, urban, region, what else? We divide up by sex and age. So we do the matching among people of the same sex and age category, but we use age within that, right, as a continuous variable. And what else? I would have to go back and actually look at the code I wrote to do the assignment, but those are the main ones. The main things that impact the amount of time people spend, which is the number of people in the household, location, that kind of stuff. Yeah, for sure.
There's one question right before from Anna Marie, or I don't know if her son, or daughter, sorry.
Yeah. Right. Why do the matches just for those who's, so the affinity score is a measure of how close each donor is to the recipient that we're trying to match, right? And so we select from the group with the highest affinity score, because that's the group that is most like the recipient, right? So we pick a donor from among the group with the highest affinity score to match the recipient, right? So the different, every donor might have a different, depending on, so donors will have different recipients, different affinity scores for each recipient, right? So some donors who are have a very low affinity score for one recipient will have a high affinity score for another, right? And so they'll be in the pool for matching for some recipients and not for others. So it all depends. With the median production hours amongst males in Ghana. Yeah, so that's what I was saying, is that the median donor has, at least for those above 18, do no household production work in Ghana at the median, right? So fewer than half of adult men appear to do any household production work. So, yeah, so I'll repeat it. Fewer than half of the adult men in Ghana do household production work of any kind. That being said, they do work generally really long hours. You know, the average work week is above 50 hours a week, I think, and it goes even higher at the upper level, but still, right? It is what it is. That's not the case in Tanzania, right? But it is in Ghana. Okay. All right. So we have 15 minutes left, right? So I just want to briefly talk about adjusting consumption expenditures, because we have to do something, right? In the employment simulation, we have changes in earnings in household, so changes in income, and we have to do something to convert that to consumption, right? So we have the new household income. So we have to make some adjustments to consumption expenditures in line with the changes in income, and also keeping in mind the predicted change in total consumption expenditures by the household sector from the CGE model, right? So basically what we do is we simulate a marginal propensity to consume that looks something like this for Ghana, separately for rural and urban sectors. And you know, there's just a parameter I choose that will give me a different curve here. And this is from 0 to 100% ratio of the consumption expenditures to threshold, right? So these are the percentiles. So I look at existing household consumption expenditure, divide by the consumption poverty threshold for the household, and that gives me a ratio. And from the lowest to the highest percentile of that ratio, of the distribution of that ratio, I alter the marginal propensity to consume, right? So for the very lowest households that are far below the poverty line, I'm assuming that they spend all of their additional income. Whereas when we get to the very highest households, I'm saying that they save all of their income, right? And in between, there's a cutoff depending. In the urban areas, it's around 25th percentile. In the rural areas, it's closer to the 50th percentile, where we start to get from 100% of all new income is spent, to where it starts to drop off, right? So, and basically I just pick parameters for this to make the total consumption expenditures add up to the number we get from the CGE model. Okay. So any questions about any or all of that? Any more questions, I should say. You already asked a bunch of questions. Well, if not, then we have a little bit of time to do some, well, maybe I should do a poll. We can do some exercises where I've prepared a data set for you, day 12, which you can use in Stata right now to calculate time deficits for individuals, households, and then calculate the adjusted poverty lines for households, and then generate the time of consumption poverty measure for individuals and households. Or we could look at some of the kind of results from the model for the next 15 minutes and talk about the total, you know, assess the total impact of the policy interventions that we modeled. We have time for one or the other, but not both. So let's do a show of hands. You can use reactions. Who wants to work on Stata? So just Daniel and Sonia. So that's 2. And who wants to talk about the results of the actual interventions on time and consumption poverty? Okay, so 5 to 2, 6. Voter turnout in this election is terrible, I have to say. Okay, so, but it seems like many more people, so you don't like Stata? What's going on here? Come on. Okay, well, the data set and the exercises are there on the page that I shared with you all. So you can take a look at those, and I urge you to do that. And if you have any questions. Louisa wants to do it all in R. Sorry, Louisa, we're not going to do that. So yeah, if you have any questions, I have office hours today at 2 o'clock Eastern time, and I've I posted the link to the Google meeting for that. So I'll be hanging out there if you have questions about Stata or anything else. And if that time doesn't work for you, just get in touch with me via Slack or email, whatever is fine. And we can work out another time to meet if you have questions that you have but can't make my office hours. Okay, so all that being said, let's talk quickly. So that this is the exercise that you're missing out on. Sad, very sad. Okay, so I'm just going to run through a couple things really quickly, and I'm just going to. I have results, a bunch of results for both Ghana and Tanzania here. So just looking at the what happens to weekly hours of employment and required household production. So this is income generating time and household production time under the various simulations, right? So you can see this is the baseline hours of employment under the baseline and total effects for men and women, right? So you can see that employment hours rise slightly for men and women on average. They rise slightly for men and decline for women on average, right? So although there's an employment expansion, it appears that the hours of the new jobs that women got are lower than the ones that men got, slightly higher. So that's Ghana overall, but that's more in the urban areas, right, for men, and in the rural area for men and in the urban area for women, right? So you can see a big decline for average hours per week for women, although that's from 45 to 43 or so, right? So for employed women, right? Employed men in urban areas are still around 50 hours per week. So that's the average, right? Then we can look at the household production hours, right? Required household production hours under the baseline and direct effects and total effects, right? So that's looking at the average hours of required household production for men and women in the baseline, the actual situation that we measured. Under the direct effects, so that's taking into account the childhood education, early childhood education expansion, and the total effects, which includes the income, the employment effects on time use within households, right? And so you can see that there's, in Ghana as a whole, in the urban areas, in the rural areas, there's very little change for men, right? The average is staying around 7 hours per week, right, for men, employed men, right? For employed women, there is slight improvement from the direct effect, and also a little bit of improvement from the employment effect as well, right? But we're talking going from almost 25 to about 22 or 23 hours per week of required household production. So this does not seem to have done much about the unequal burden of unpaid care time for women in Ghana or in Ghana. Right? Okay, I'll show you the same thing for Tanzania.
Excuse me, Tom, I'm not sure if Ileana has a question or comment. Your hand is up.
Oh, I'm sorry, I didn't see your hand. Go ahead, Ileana.
No, sorry, it was from before, from the survey about that. Sorry.
Okay, so you really, really want to talk about the results. Gotcha. Okay, so this is the average weekly hours of employment and hours. So basically the same thing for Tanzania as we just looked at for Ghana. And you can see there are similar overall patterns, right? So higher average work hours for employed men than employed women, although the difference is bigger in Tanzania than in Ghana. Higher required hours of household production for women than for men, although the hours are higher for both men and women in Tanzania than in Ghana on average, right? And you can see that for women in Tanzania as a whole, and especially in urban areas, the direct effects are what are making the change. In rural areas, there's a very slight change as a result of the employment simulation, but not that much, right? So very similar. Also, there isn't really that noticeable an effect on average hours worked in Tanzania, as we saw in Ghana, which was here, right? So you could actually see that there was a slightly higher employment hours for men and lower for women, especially in urban areas in Ghana, whereas in Tanzania, you know, it looks like slightly higher for women and lower for men in urban areas in Ghana, right? So, and this is in terms of total effects. So this is partly due to commute times, which frankly are, you know, a bigger problem in many cities in Ghana and Tanzania, and partly due to employment changes, right? But there you have it. Now, looking at time poverty rates, right? So this is individuals who are employed and have time deficits, right? So most people who have time deficits are working in income generating activities in both countries, right? And in most countries that we look at, because it's the combined effect of household production requirements and work for income generating activities that produce time deficits for most people. But as you may not be shocked to learn, time poverty rates are generally higher for women than for men. And you can see that the average, right, is the blue bar. Red is men and green is women. So overall, in the baseline, the time poverty rate is about 34% for employed persons. So 1 in 3 employed persons suffers time deficits, but that's less than 1 in 4 for men and almost half of employed women, right? The direct and total effects don't change much for men. They do reduce, the direct effects reduce time poverty rates for men slightly, but more so for women, and the total effects do much more for women than, you know, where there's very little change for men at all. You can see that time poverty rates are higher in urban areas than in rural areas, right? This is partly due to commute times, but also due to longer hours at employment in urban areas than in rural areas. But in both urban and rural areas, there's a big gap between poverty rates, time poverty rates for men and women. Okay, so that's Ghana. Okay. I'm wondering why this is a different graph, but it's the same information, but a different presentation, unfortunately. Oh, that's right, because I fixed this one, and I didn't fix this one. I apologize. So this is rural. This is for urban men, urban women, right? This is rural men and rural women who are non-poor and poor in terms of consumption poverty status, right? So you can see in terms of time poverty, there is not a huge difference in the incidence of time poverty between poor and non-poor households, right? Poor and non-poor in terms of consumption expenditures, right? The poor households have slightly lower, men in poor households have lower time poverty in urban areas, as well as women in poor households have slightly lower time poverty. But in rural areas, women in poor households have higher rates of time poverty. And again, in Tanzania, the difference between men and women in urban areas is smaller than in rural areas, but in both, right, the time poverty rates are higher for employed women than for employed men, right? And nearly double in the baseline between men and women in rural areas. Okay. Okay. Let's. So I'm just going to. Okay. This is the last thing I'll show you. This is the time and consumption poverty characteristics of employed persons by sex in Ghana in the baseline as a result of direct effects and the total effects. So you can see, so between these three, there's not that much difference, right? So the blue is where you least want to be. This is where you most want to be, because the blue is both consumption and time poor. This is neither consumption nor time poor. The orange is consumption poor, but not time poor. And then the gray is consumption non-poor, but time poor, right? So blue and gray added together is the time, those who are time poor. The blue and orange together are the consumption poor. So consumption poverty, you can see declines overall as a result of the entire simulation, taking into account employment and direct effects. But it doesn't, the direct effects of the time poverty gap, as well as the rates. Yeah, Mingtan, in the report there are all the graphs are in the report, but I'm not going to do that just now. But yeah, it's in there. So very long story short, you know, men are much more likely to be in the happy category of neither time nor consumption poor. The rate of consumption poverty is about the same between men and women, because men and women are equally likely to live in poor households, right? But the rates of time poverty are much higher for women. That's why you see the much higher incidence of time and consumption poverty for women. It's reduced by about 3 percentage points for women in Ghana, but that's still twice as high as the rate for men. Okay, so that's kind of where I have to stop, since we're at 11 and we have to have a break and still have time for Martín.
Welcome to the second session on macro modeling the care economy with me, at least my part. And do we need to turn in the first macro exercise sometime? Oh, there is a question in the chat. No, the exercises that you have at the, I guess, she's talking about the exercise that I posted on the website. Those are optionals. I mean, I would be more than happy to have a look at them, but they are not, you don't have to send them to me. It's just for you to practice, but I will be happy to have a look at them if you want. Okay, so the plan for today is to go back to the social accounting matrix that we saw the other day, and we will discuss why it is a good idea to think about these issues in a general equilibrium model. Then we will extend the social accounting matrix to cover care and the non-GDP economy, basically, as we were calling it the other day. And then we will start talking about the specific CGE model. We will start with a small model, and then we will move to more complex models that will have like features related to how can we model the care economy, and how can we model male and female labor, and how can we model the substitution between male and female labor, both the GDP and the non-GDP sectors. Okay, so first, any questions related to what we saw the other day? No? Okay, so then I will go to the presentation. Let me just share the whole thing. Okay, so here we are. So as I was saying, we will start by discussing why it is a good idea to use a CGE model to talk about these gender issues and specifically for the analysis of care. So why it is a good idea? As we saw the other day, in a CGE model, what we do is we model the whole economy. We have all the components of a real economy inside the computer, basically. And the value added of doing general equilibrium analysis is that we are going to be able to ask questions to the model within a context of consistency, let's say, okay? So if the government is increasing spending, someone will have to be paying, for that additional spending, okay? So and the same for the households. If there is an increase in household spending, that means that the money is coming from somewhere, either transfer, a remittance, or whatever, but it has to be paid by someone. Okay, so that's why we do CGE model in general. So then the question is why it is a good idea to use this type of method for the analysis of care, okay? The answer is that by thinking about these issues in a general equilibrium model, we are going to take into account the links between the care sectors, both at home and in the market, female labor force participation. We can also take into account the gender wage discrimination. And we can look at different social and economic outcomes, such as the time used for women and men inside the home and also outside the home. We can take into account household well-being. And as we were discussing, we can take into account both the GDP and the non-GDP production sectors. And we can also have a look at, we will also take into account the fiscal indicator, the balance of payments, so all the components of an economy. And we are going to be doing all this within the context of a single model, which means that everything will be considered within a single framework, let's say. And all these reasons are the ones that we had to develop GEMCare in the first place. So, and GEMCare is the model that we developed for the American University project on the care economy. And as I will be discussing tomorrow, it has it's a descendant of other models that have been developed in the literature and also by Hans and myself. So that is why we think it is a good idea to think about these issues in a CGE model. So once we have the model, we will be able to ask questions such as what would happen if this or that changes. Okay, so we will have a kind of lab in which we can ask questions, keeping everything else constant. Okay. Okay, so this is the social accounting matrix that we saw the other day. This is a fairly standard social accounting matrix. We have activities, commodities, factors such as labor and capital, taxes, and institutions such as the households, the government, and the rest of the world. And we have a savings investment account. So in this framework, we don't have anything related to the non-GDP sectors, and that is what we are going to add now. So what are we talking about? This is something that you have already discussed during the course. So what we have within the domestic and the care sector, we have the housework and the care of persons. Those are the two components of the non-GDP economy that we are going to add to the social accounting matrix, and that will also be captured in the CGE model. The part that is paid is already there. The part that is non-paid is the one that we will be adding now to the social accounting matrix. Okay. Okay, and I will be using an example for Korea. This is a social accounting matrix for Korea 2018. In building this social accounting matrix, we used two main data sources that are non-standard. Remember from the other day, what we usually need to build a social accounting matrix are the national accounts. And within the national accounts, we need the supply and use tables. And if we are lucky enough to have them for a particular country, the integrated economic accounts. And if we don't have the integrated economic accounts, we can replace them with data on the government budget and data on the balance of payments. In the case of Korea, we have a very nice set of national accounts. And to build this extended sum, we combined the social accounting matrix with a time use survey. And in the case of Korea, we also had access to the household production satellite account, which is basically based on the time use survey. It's like a processed version of the time use survey. And actually, what we have in the household production satellite account is similar to what we are doing to extend the social accounting matrix. That is not really something that is needed to extend the social accounting matrix. But if you have it, it's a good thing. Okay, so what's the problem, or what's the most difficult part of extending the social accounting matrix in order to cover the care economy and the non-GDP sectors? Okay. First, we need to know the amount of time that the different individuals within the different households are spending on unpaid domestic and care work. Okay, and that we can know that from the time use survey, and you know this already. Then, in order to introduce this information into the social accounting matrix, we need to provide, let's say, the value to that time, and for that we use the replacement cost approach. We ask how much money is needed to buy the same or similar, actually, a similar service within the market. Okay, and that's the replacement cost. So instead of me taking care of the kid, I will pay someone to take care of the kid. The amount of money that I need to pay to that person, that will be the replacement cost, or the same for a cook. So in that case, we use the wage of a worker that would be doing similar work that I was doing at home. Okay, then, given that in the social accounting matrix, but most importantly in the model, we are interested in capture like the time use of the different household members, how much time they used in work at home, in work outside the home. We are also interested in capture the leisure time. And we are interested in allowing the household members to switch between leisure and work within the home or work outside the home. So we need to expand the social accounting matrix to also cover leisure time. It's the same approach. From the time use survey, we know the amount of time that each individual is spending on leisure time. We do not consider time that individuals spend like sleeping or studying. That will not be covered by the sum, and that will not cover by the CGE model, in the sense that we are going to assume that that time will be exogenous. Okay, so we are not modeling the 24 hours, we are modeling only part of those 24 hours a day. In the case of leisure, we also need to give a value to that time, and for that we use the opportunity cost approach, which is we basically look at the average market wage for the different individuals, and that is the wage that we use to value each hour of leisure time. Okay. Once we do that, in the case of Korea, we have a sum with 121 activities, 101 activities and 107 commodities. And we have 11 factors because we have 4 labor categories, male, female, and within each of them, we have skilled and unskilled workers. Then we have unskilled workers are those with more than secondary education. But the sum as a framework is flexible in that sense. So depending on the context, you may need to use different categories. Like for a developing countries, for a developing country, if we have 2 skill categories, we will use a different split between labor categories, not less than completed secondary and the rest. Okay, so then we have capital, land, and other natural resources. And in this case, we have 6 institutions. We have 3 households, 1 enterprise, the government, and the rest of the world. What's there? Sorry. Okay, sorry about that. I was saying that we have 3 households, and we split the households based on their care needs. So we have that one representative household that refers to the households in which the household head is an elderly person, which means it's 65 years of age or more. Then we have another households in which the head is at the working age and has kids, so household with kids. And then the third one is a household, a representative household with the head of the household at the working age, but without kids. So we split the households in the social accounting matrix and then in the model according to their care needs. And actually this is, as far as we know, this is the first time that that is done in a SAM and in a CG model. So it's a very interesting, we think, what we can say once we split the households according to their care needs. Okay, and remember that in the national accounts, we have only 1 household. That is what we usually call private consumption. And so we use information from the different household surveys to split that single private consumption, in this case, into 3 different representative households. So what we do is we go to the household survey and we link each of the individual households in the household survey to one of these 3 representative households in the social accounting matrix. Okay. Before I said that we split labor according to their skill levels. For that, what we do is, as you know, in the national accounts, we only have information on total labor payments. So we need to split that information between different skill levels. And for that, we also use a household survey, because for each individual, we know if this individual is working or not. And if it's working in a GDP sector, we know in which sector, and we know the labor income. And so we use that information to split, and we also know the skill level, of course, and we use that information to split the labor payments by the different activities across the different skill types or labor types. Okay, So the non-GDP sectors of the social accounting matrix are the ones that I mentioned before. We have domestic services, caregiving services produced by the household and family members within the households. And we have leisure. And as I was saying, we do not consider time spent sleeping on education. Okay, and this is how the sum looks like when we extend what we saw the other day to have these two types of non-GDP sectors, the care non-GDP sector and leisure. Okay, and I see a question here. What is the reason for excluding personal care? Is it valuation issue? That's a very good question. It's the reason for not consider personal care is that one is valuation, and the other one is it's difficult to model the determinants within the CGE model. So basically, we say, okay, this is the amount of time that we will assume each individual needs for personal care, and we are not going to model that. Okay, but that's a decision that we made. In principle, it could be possible to cover the 24 hours. We just have to think how to do it. Okay, so in this case, I'm only showing the same social accounting matrix that I showed the other day with these three additional sectors. So in total, we only have 5 sectors, 5 activities, and 5 commodities. But this is only to fit the social accounting matrix in the PowerPoint. I will share with you the big sum. Okay, that will be part of the model database. Okay, so let me explain how this works, because that will help us understand how the model works in the sense of how we are modeling these non-GDP sectors or the production of care services within the household. And it's the same for leisure, the same idea. So by doing what I said before, which is going to the time use survey and valuing the amount of time that household members use for producing these household services, that is what we have here. And in this social accounting matrix, we only have one household. Okay, so what we have here is the amount or the value of the time that women spend on producing household services. Okay, and here, instead of using wons, which is the currency in Korea, I'm showing the numbers as GDP shares. So the amount of time that women spent working within the household, that was equivalent to 20.2% of GDP. And for men, that amount was equivalent to 4.2% of GDP. Okay, and you see here, or we see here, that we are recording that as a payment from this new activity to male labor and female labor. Okay, so the total value of these care sectors the total value of the production of these care sectors is equivalent to 24.4 of GDP. And we see that that is the total cost of producing that. And we are assuming, given the lack of data, that we only use labor to produce that, mostly female labor. And that is the total cost. And the whole production goes to the market. This is the domestic supply of non-GDP care services or unpaid care, the same number here. And if we look at the row of this column, this commodity, we see that the only institution that is paying for that commodity are the households. Okay? And at the same time, we also see that the labor factors are making a payment to the households, mostly. Okay? And in this case, it's trivial because we only have one household. But once we have more than one household, we have to be sure that the amount of money that each household is spending on these non-GDP services is consistent with the amount of labor that these households are spending on producing these household services. So this is how it works. The idea is that the household is producing these household services, it's getting labor income, and at the same time is buying those services for its own consumption. Okay? So in a sense, it's like having a transaction that does not go through the market. Okay? Because it's the household producing using its own labor and using that money from that labor income to buy the output of these household services. Okay, and it's the same with leisure. The only difference is that for leisure, we assume that it's not possible to substitute male labor with female labor. That is, we have two different leisure activities, one for males and another one for females, because the assumption is that we cannot substitute, I cannot substitute my leisure with my wife's leisure, let's say. Okay, but then besides that, the logic is the same. So I have a question: do they trade between themselves, or is these services that are consumed as they are produced? No, these are not traded, in the sense that this labor has to be linked. The amount of labor that goes into the production of this particular activity, which is the non-GDP activity, has to be linked to one particular household. And that is the only household that will be able to buy those household services. So in that sense, there is this transaction does not go through the market. It stays within the household, let's say. So they are consumed as they are produced. So there are no, as you can see here, we do not apply any trade and transport margin to these non-GDP services. Okay, other than that, it's the same as we saw the other day. And what is really important for us is that when we look at the CGE model, we are going to be following the same logic when modeling the production of household services and the production of and consumption of leisure, let's say. So for example, when we look at the total income of the household, which is in this row and the column total, this is the total income of the household. Here, the income of the household, it's expanded with the valuation of the household time that it's being used to produce household care services and household leisure. So it's not the usual idea of income that we have in the national account, in the national accounts. Here it is expanded with the amount of labor. Of course, it's the quantity of labor times the wage that goes into the production of household services and leisure, which means that when we think about the tax base for the direct tax, the income tax, this is the amount that the household is paying of the income tax. You can see this is a payment from the household to the income tax. And then the income tax goes to the government. You see that here. So once we move to the modeling, we have to be careful in the sense that the tax base for this income tax cannot be this total income of the household. It has to be household income from GDP activities, because at least up to now, the government is not able to tax the production of non-GDP services and also the production of leisure, let's say. Okay, so I hope it's clear. Let me go to the next one. Here you have the meaning of the different accounts in the social accounting matrix so that you can follow the presentation. And here we have some data or some figures that you can extract from some information that you can extract from the social accounting matrix. So here we have trillions of wons, okay? And what we show here is the composition of the GDP, the sectoral composition of GDP in Korea in 2018. We see that industry is a large share, of course, also services. This part here, those are care services within the GDP. And here in the second bar, we have the GDP plus the non-GDP sector. So this is the new part. This is equivalent to 24.4 of this part. And here we have the production of non-GDP care services. This is the total. We have here like domestic work, then we have child care, and then this small one is elderly care. Okay, so those are the three components of the non-GDP services that we have in this social accounting matrix. And as I was saying before, we split them based on the different households that we have in the social accounting matrix. Okay, then we can look at the gender composition of the labor demand by the different activities. And we see that the GDP sectors, except care, are relatively intensive in the use of male work. Then the care sector, both at the GDP and the non-GDP, are relatively intensive in the use of female labor. This is the orange one. And then we have leisure, we have male leisure and female leisure, okay? Okay, so this is data that will be very useful when we look at the results from the CG simulations. Okay. And then we can also have a look at time use by gender. Again, this is the share of the total hours by the different labor factors. So we have the 100, but this is the total time available for the male labor for skilled workers. And this is the share that goes to industry, the share that goes to services. And here we have the share that goes to the non-GDP sectors. Okay. And again, we see that for women's, the share of time that goes to the non-GDP sectors is much larger than for men. Okay, so questions on the social accounting matrix? Okay, so that is how we can expand the social accounting matrix to have the non-GDP sectors. Okay. So now let's move to the next presentation, and you have all these presentations available at the website that I prepared. And now the idea is to move from the social accounting matrix to a CGE model. We already discussed what is a CGE model, so I will go quickly through that. And I will try to cover today as much as I can of the structure of this relatively simple CGE model. Okay, so the idea is to show you some of the equations, sorry, not some of the equations, all of the equations of this simple CGE model. And we will be looking at how this model works. And once we complete this model, we will move to the next one that also covers the non-GDP sectors, because this first one covers the GDP sector. And then we will have a more complex model. Actually, the first two are the same model. What we basically change is the social accounting matrix. First, we will use this model with a simpler social accounting matrix, and then we will cover a more complex social accounting matrix. Okay. Okay, that's the doorbell. Okay, so we know that the social accounting matrix provides like a picture of the economy. That's our benchmark equilibrium. And it's only a picture. We don't say nothing about behavior when we have a social accounting matrix. I think you used the social accounting matrix as the basis of the model that you use with the Levy microsimulation model. Here we are going to use the model to calibrate here we are going to use the social accounting matrix to calibrate the CGE model, which is a different type of model. Okay. Okay, so we already discussed about this having flexible prices, substitution, and different behaviors within the CGE model. Okay, so we are going to have some equations and variables within the CGE model that are going to be linked to the different cells in the social accounting matrix. And what is interesting is that you can always rebuild the social accounting matrix using the results from any CGE simulation, because you use the model you use a sum to calibrate the model, and then you can use the model to replicate the social accounting matrix in the absence of shocks, or produce social accounting matrix for the different simulations that you run with the CG model. And I will talk about calibration later today or tomorrow. Okay, so we already know what is a CG model. We know that it's we can solve the model numerically, and that's why we are going to have numbers. We will be able to say this goes up and this goes down, but we are going to be able to say by how much. Of course, we will be doing some assumptions in order to be able to say that, but that's the price we have to pay. Okay, and as I was saying the other day, we will be assuming that the consumers and the producers in our model, they know economics and they know microeconomics. So they will be maximizing utility, they will be maximizing profits, and they will be reacting to relative prices. Okay, so we start with a simple model. In this model, we are going to have activities, commodities, factors, households, and we are going to have a government. In this first application, we are going to have 3 activities, 3 commodities, 3 factors, and 1 household. Okay, and the factors are going to be male labor, female labor, and capital. And for the government, we are going to assume that the income tax rate goes up or down until the government budget is clear. Okay, so if we simulate an increase in government spending, that means that the income tax rate will automatically go up until the government budget is cleared. Okay, and that is called the macro closure for the government for the model. Okay, the government macro closure. Okay, so which are the simplifications that we are going to be making relative to the real world or relative to a more complex model? We are not going to be modeling savings and investment, and we are going to be working with a closed economy model. Okay, so those are the 2 things: no savings, no investment, and no rest of the world. Okay, so as I was saying before, the size of the model will be a function of the database that we have. So you will be able to build a larger database and use it to run this model without having to make any change to the model code. So the way in which the model is coded is with a complete separation between theory and data. Okay, so the model adapts to what we have in the data. And I have a question here: do you include government subsidy in the model? Yes. Let me go to the sum. So this is the social accounting matrix. I will answer the question by looking at the social accounting matrix. Okay, so the question is related to government subsidies. If we look at the social accounting matrix, we have an account for taxes on commodities. Okay, and I will repeat something from the other day. So this is the social accounting matrix for this particular model. So we don't have the rest of the world. We only have households and the government, and we don't have savings and investment. Okay, apart from that, it's very similar to the social accounting matrix that we saw the other day before what we added today that was related to the non-GDP sectors. Okay, so here we have the intermediate consumption, value added of factor payments. Here we have taxes on activities, or these are taxes on production. And this is the domestic supply at basic prices. And remember, basic prices are prices at the factory gate. Okay. And here we have the domestic supply at purchaser prices. And this used to be called market prices. Okay, now it is called purchaser prices. Okay, and in this small model, the difference between basic prices and purchaser prices is that we have commodity taxes. And you can see again that commodity taxes, they go to the government. Okay. It is possible to have an additional account to cover commodity subsidies. Okay, that is possible, and the same for subsidies on activities. Here, we are assuming that these are net commodity taxes. Okay, but the short question, the short answer to your question is that yes, it is possible. Here we only have net subsidies, net taxes. Okay. Okay, so the implications, what are going to be, there is another question here. What would be the implication of including the rest of the world and savings and investment into the model? So the implication is that, and this is more like the discussion. So the implication of having the rest of the world is that we have to explicitly model basically all the transactions that we find in the current account of the balance of payments, at least in the simplest case. Okay, so what do we have in the current account of the balance of payments? We have exports, imports, transfers to and from the rest of the world. For example, a transfer from the rest of the world to the government, that foreign aid. And we can also have remittances, that the transfer from the rest of the world to the household in the economy that we are modeling. And we also have factor income. Okay, so if there is a foreign company or a foreign enterprise producing in the domestic economy, and this company sends capital income to the rest of the world, that goes into the current account of the balance of payment, and we have to model that. Okay, so the implications of the model is that first we need to model international trade, and once we have international trade, we also have the rest of the world, and then we need to cover all the transactions, not only trade, that the rest of the world makes with the households and the government. Okay, so in the previous presentation, we had those transactions in those transactions in the social accounting matrix. We have to cover that also in the model. Okay, I will say one more thing about the issue of trade. If you remember, or yeah, I mean, it seems to me that most of you have gone through some courses on economics and hopefully also on international trade. And if you might remember from international trade that the textbook assumption is that domestic goods and foreign goods are exactly the same. They are perfect substitutes. Okay? Okay, so they are exactly the same. And that means that if what the country produces, it's the same as what the country can import from the rest of the world, and it's the same as the country could export to the rest of the world, that means that it doesn't make any sense to have the same good being exported and imported at the same time. Okay, so if let me give you an example. If French wine is a perfect substitute for Argentinian wine, it doesn't make any sense to have wine exports from Argentina to France. Okay, but then if you look at the data, you do see, believe it or not, exports of Argentinian wine from Argentina to France. And of course, you do see imports of French wine into Argentina. Okay, that is something that you see in the data, but that a model that works under the assumption that commodities are the same, irrespective of which country is producing them, that model cannot capture that. So in the model, once we open the economy, we are going to assume that domestic goods are an imperfect substitute for imported goods. Okay, and we are also going to assume that selling to the domestic market is not the same as selling to the rest of the world, as exporting. Okay, so this idea of imperfect substitution, that is something that we are going to use a lot in the model. Okay, and actually in this simple model, we are going to assume that male workers are an imperfect substitute for female workers. And once we move to the next model, we are going, or the next data set, we are going to assume that for the household, care services from the GDP sectors are not the same as care services from the non-GDP sectors. So care services produced within the households are going to be an imperfect substitute for care services produced by the market. Okay, so those are going to be key assumptions in our modeling. And for modeling that imperfect substitution, we're going to be using CES function, this constant elasticity of substitution functions. So in the I added you have an exercise on that in the website, and I will be more than happy to share additional references on CES functions in case you don't remember them well. Okay, so before we go into the discussion, let me show you this figure. This is what we have in the model. Okay, so we are going to have commodity markets and factor markets. The activities are the ones that produced. Then we have households and the government. And these are the arrows shows the flows. Actually, they show the money flows from one component to the other one. And it will usually be the case that in the opposite direction, there will be a flow of factor services or commodities or goods and services, except for transfers. Okay, so in this model, the government will be making transfers to the households, and we will also be covering government consumption. Okay, so the sum, this is what I was talking about. This is what I was saying before. We have the output. Producers are going to combine value added and intermediate inputs, and within value added, we are going to have capital, male labor and female labor, and then we are going to make this production function more complicated. But for starters, this is going to be our production function. And the next step is to look at the equations. Okay, this is the notation, and then we look at the equation. Okay, so tomorrow we are going to look at the equations in detail, and we are going to be running some simulations because I think we still have some time for some discussion. I don't know if, did I miss any question from this chat? No. Okay. So we still have some more minutes to discuss. And if you would like to, before tomorrow's session, which will be, we are going to have more time tomorrow, so we are going to cover this model and maybe the next one. If you would like to have a look at the rest of the presentation, you can have a look at the model equations and the notation that I used. Okay, and here there is a question. And the elasticity of substitution that we use in the CA function. What is the, this is a good question. So I was saying that there will be a imperfect substitution between home-produced care services and market-produced care services. Okay. And the question is, if basically what's their value? Okay. So actually, and then if the same elasticity is for between men and women. Okay, so there are two things here. One is within the household, what is going to be the elasticity of substitution between home provided services and market provided care services. Okay. And then the elasticity of substitution between male and female work or labor for the production of household services within the household and the production of GDP commodities outside the household. Okay, because we have to combine these two different labor categories, both within the household and also outside the household. And the truth is that we don't have enough econometric or work to give values to these elasticities, and taking into account that this elasticity basically reflects social norms, okay, especially the substitution between male and female workers within the households. What we do is we use a relatively low elasticity, okay, basically less than 1, which means that the two inputs, male and female labor, the two inputs are gross complements. Okay, it is difficult to substitute one for the other one. And if you don't remember the concept of elasticity of substitution, just think of an indifference curve. Okay, and the higher the elasticity, the closer is the indifference curve to a straight line. Okay, once you have an indifference curve that is a straight line, that means that the elasticity of substitution is infinity. It's infinite. Okay, basically the two inputs are exactly the same, so they will have the same price. Okay, at the other extreme, you have an elasticity of substitution equal to 0, and that means that it's not possible to substitute one input by the other one with the other one. Okay, those are the two extremes. Okay, so we are going to assume that the possibility of substituting female labor with male labor is relatively low, but the nice thing about having this CG model is that we can ask what would be the impact of increasing or decreasing all these elasticities. Okay, what would be the impact of making this elasticity higher? Okay, and then there is the issue of, would it be possible to make these elasticities endogenous? Okay, that's for another session. Okay, but that's basically the idea. So remember, we are going to have two different elasticity of substitution. One that refers to the substitution between home-produced care services with market-produced care services, and the other one for the substitution between male with female labor. Okay, and the implication is it's difficult to substitute. Okay, yes, a sensitivity analysis, that, I mean, that is always needed when you use a model in which you are not sure about the elasticities. Okay, that's not specific of this case. That is something that, I mean, at least if you ask me, that is something that you always have to conduct, a sensitivity analysis. Okay, ask the model, what would happen if I increase or decrease these particular elasticities? And actually, when you do this sensitivity analysis, you really learn how your model works, and actually you may learn that you need to fix your model or you may learn that the elasticities that you are using must be replaced. Okay, so the sensitivity analysis is key. And you can run it in a very fancy fashion, like doing Monte Carlo simulations, in which you run your model several times, using each time a different set of elasticities. And then you can see how the different results depend on the elasticities. I was left with the previous question, the selected household with children, what ages of the children do you take into account and disabilities are taken? Okay, that's a good question. In the particular application for Korea, what we did is we split households in 3 groups, and those with what we call children are children aged 6 or less, okay? And individuals with disabilities, we do not have an explicit household category for those households, so we have them together with those with the children. Okay. Will wage differences just follow from that assumption? Actually, wage differences, they are data driven, okay? Because we know in the data, in the sum, we know total wage payments by the different activities, and then we also have the time, the number of hours in the different, by gender and in the different activities. So the wage difference, the different wages, we know them simply by taking the ratio between what we have in the social accounting matrix and the total number of hours that go into the different activities. Okay, so those differences are data driven. And then given that we assume that those are imperfect substitute, we assume that those differences are endogenous. Okay. Okay, and then the question on making those elasticities endogenous, that is technically possible. That's not something that is usually done. Okay, I think I ran out of time. Okay, if I want to keep the time in check, that could be it. Okay, unless there is some other questions. Okay. So, Anai, should I say something else or how do I finish?
No, I think that is it for today. I don't know if you were able to answer Ana Maria's Maqueiras, making elasticities endogenous is something that can be done within the CG framework.
Yes, I mean, it can be technically done. Then the question is, what are the determinants of those elasticities? And the difficult part would be to think about the micro. What are the microeconomics behind doing that? But technically it is possible, and one could argue that it would make sense to make those elasticity endogenous. Like, for example, next we're going to see. So the answer is yes, not okay. So next we are going to split the total labor income into labor from GDP activities and this income from household services, okay, which do not go through the market, okay. And one could argue that these elasticities, or the elasticity of substitution between male and female work within the household, is a function of the GDP labor income of females relative to that of males, of women relative to that of men. Okay, so the larger the contribution to GDP income from women relative to men within the household, one could think that elasticity is higher, or that elasticity increases, endogenously increasing. And why it's not usually done? Because it's difficult, and because we don't know getting the micro right. It's not simple. Okay, but that's the reason. Yeah, and I agree. It's very, very interesting.